Hi friends, now let's continue solving another problem. The problem of finding a clique in a given graph. A clique is a subgraph that has fully connected. A fully connected subgraph of any graph is called a clique. So here we are interested in identifying whether the particular thing has got a clique of particular size or not. So that's a decision problem. And we want to prove that this clique problem is a NP complete problem. So as usual, we try to convert a three-side problem, reduce it to a clique problem in polynomial time, and then if we could find a clique solution, then the same solution can be mapped back to the three-side problem, and let's verify the answer. So let's jump into the solution. So that's a three-side problem we have, and for this three-side problem we build a graph, and the graph building is for every clause we have three vertices. So x1 bar, x2, x3. So this is for clause 1, and for clause 2 we have x1, x2, x3 bar, and for clause 3 we have x1 bar, x2 bar, and x3 bar. Let me just make it look better. Okay, that's way. Now to create a graph for working with the clique is simple. So from every clause, the node of every clause, we connect to the nodes of other clauses so that the connection is not between the complement of each other. So if it is x1 bar here, then it should not be connected to x1 because these two cannot be uh, true together. So if x1 bar is true, then x1 has to be false. Therefore, we can't connect between x1 and x1 bar. But yes, x1 bar, x2, there can be connection. x1 bar, x3, there can be a connection. So x1 bar, no problem. x1 bar, x2, x1 bar, x3 bar, no problem. x2, x1, no problem. x2, x2, no problem. x2, x3 bar, no problem. x2, x1 bar, no problem. x2, x2 bar, we can't connect. x2, x3 bar, no problem. x3, x1, no problem. x3, x2, no problem. But x3, x3 bar cannot. So x3 with x1 bar, no problem. x3 with x2 bar, no problem. But x3, x3 bar, we have a problem. So now between these two, between these two, we have looked at. Now with this, we have done anyway. Now from here, x1 bar cannot be done. x1, x2 bar can be done, and x1, x3 bar can be done. From x2, x1 bar can be done. From x2, x2 bar cannot be done. From x2, x3 bar can be done. So now we have three clauses. Sorry. Therefore, we need a clique of size 3. 3 clauses means 3 sized clique is required so that three-sided clique is a triangle. So try to identify a triangle in this. So what could be triangle? So x1 goes to x3, then goes to x1 bar, cannot go back, x1 to x3, x3 to x2 bar, x2 bar to x1 it can go. Okay. So from 1 it can go to x3, from x3 it can go to x2 bar, from x2 bar it can go back to x1. So yes, we found one clique. So that way many triangles may be possible. So just by luck we got this triangle. So it is trying to say that x1 is 1 and this is saying x2 is 0 and this is saying x3 is 1. So this is talking of this end, this end and this end. So we can have many such possibilities like x1 bar here, x1 bar here, then what, not there, x1 bar here, x2 bar here. No, so from x1 bar you can go to x2, x2 to x3 bar back. Yeah, that's another possibility. x2, x1 bar to x2, x2 to x3, x3 to x1 bar possible. So that talks about x1 bar, x2 and x3 bar. So this says x1 is 0, x2 is 1, x3 is 0. So whether it is this combination, then there is a clique. So for this combination, the clique is yes. For this combination, the clique is yes. So if we substitute these values, let's see what all happens. So first let us try this. x1 is 1. So this is 0. So this is 1. This is 0. x2 is 0. So we have a 0 here. We have a 0 here. We have a 1 here. And x3 is 1. So we have a 1 here. We have a 0 here. We have a 0 here. So one of them is true. So this clause is 1. One of them is true. So this clause is 1. One of them is true. So this clause is 1. 1 and 1 and 1. Therefore, it makes this true. So here we found this triangle. This is a clique. So it says that the clique, whatever we said, x1, x3, x2 bar, can it be a clique? Yes, it is a clique. So the answer to that is yes, there is a clique. And this also said that yes, this is satisfiable. Okay, now looking at other combination we had, x1 is 0. Therefore, x1 bar is 1, x2 is 1, so this is 1, x3 is 0, so this is 0, x1 is 0, so x2 is 1, x3 is 0, so this is 1, x1 is 0, so this is 1, x2 is 1, so this is 0, x3 is 0, so this is 1. So you can see that one of them is, at least one of them is high. Therefore, this is 1, this is 1, this is 1, 1 and 1 and 1 will get a 1. So there are many such solutions possible. So accidentally we arrived at this one and we found that yes, it forms a clique, and that values if substituted here, it says yes, it is satisfiable. Accidentally we found another solution, and substituting here we found that it is verified that it is satisfiable. So in all, you can say that the three-side problem was reduced to a clique problem in polytime, and the solution, so what we say, sorry, non-deterministically found. Because finding solution is an exponential problem, so a solution of a clique, if used in 3-sat, we found that it is satisfying. So that means the result of if you can find some solution for clique problem, and that is going to solve the 3-sat problem also. So we hence claim that 3-sat problem is reduced to a clique problem, and we know that this is a NP complete problem, and hence we prove that this is also NP complete problem. So that's the proof that clique problem is indeed a NP complete problem, and many such problems we can look in coming future. So please keep watching. Thank you.